Hello everyone, today we're going to do chapter 4, Tangents and Circles, prepared by Imad Ahmaidan and registered by Ahmed Hamad. This is the correction of the homework exercise 2 from the sheet for grade 9. So please stay focused and let's begin. Consider a circle C of center O and radius 3 cm and diameter AB. E is a point such that OE is equal to 9 cm and AE is equal to 6 square root of 2 cm. OE cuts the circle C at H. The questions: 1. Draw the figure. 2. Show that AE is tangent to the circle C. 3. The tangent to the circle C at H cuts AE at F. A. Show that the triangle AFIH is isosceles with vertex F. B. What does FO represent? Do the angle HFA and justify. C. The perpendicular bisector of FO cuts FH at S. Show that SO is parallel to AE. D. Deduce that the triangle ASB is isosceles with vertex S. 4. Show that the 4 points A, F, H, and O belong to a same circle and determine one of its diameter. The solution now. Consider a circle C of center O, radius 3 cm and diameter AB. This is the circle C. It's called C between parentheses and of center O. Its diameter is 6 cm because the radius is 3 cm, because the radius is always half of the diameter, and the diameter is called AB. We have E is a point such that OE is equal to 9 cm and AE is equal to 6 square root of 2 cm. Draw the figure. So we put the ruler. 6 square root of 2 is equal to 8.5 cm. Using the compass, we open the compass on the ruler for 8.5 centimeter and 9 centimeter. So we start first of all with 9 centimeter. And we put the compass on the sharp side of the compass. We put it on the center of the circle, and the other side we just draw a semicircle or an arc. And then we open the compass again on 8.5 centimeter, which is 6 square root of 2, and we put the sharp side of the compass on A, and then we draw another small arc. The intersection point between these two arcs will be the point E, because E must have the distance between E and O equal to 9 centimeter, and at the same time between E and A 6 square root of 2, which is 8.5 centimeter. This is how we draw the point E. So we draw the line between E and O, and another line between E and A. OE cuts the circle C at H. So the intersection point between OE and the circle C is called H. Show that AE is tangent to the circle C. We have to show that the side AE or the line AE is tangent to the circle C. Apply converse of Pythagoras relation in the triangle OAE. So we have OA squared is equal to 3 centimeters squared, which is the radius of the circle, which is 9 centimeters squared. And AE is equal to 6 square root of 2 squared, which is 36 times 2, which is 72. And then we have OE is equal to 9 squared, which is 80 1. Since 81 is equal to 9 plus 72, that means that OE squared is equal to OA squared plus AE squared. That means that the relation of Pythagoras is applicable here. And that means that there is a right angle at A. And the triangle OEA is a right angle triangle. And we can, in this case, apply and use the relation of Pythagoras. So as there is 90 degrees at A, that means AE is perpendicular to OA, and EA cuts the circle C by only one point, which is A, perpendicularly to the radius. That means EA is a tangent to the circle C. The tangent to the circle C at H cuts AE at F. So we have to draw another tangent to the circle C that cuts the circle C at H. Because as we said previously, the tangent to the circle cuts the circle only by one point and perpendicularly to the radius of the circle. So we draw a tangent to the circle C that cuts the circle C at point H perpendicular to OH, which is the radius. This tangent cuts EA at point F. Show that the triangle AFH is isosceles with vertex F. So we have to look at the triangle AFH. Since HF and AF are tangents to the circle, so HF is equal to AF. So the triangle AFH is isosceles at vertex F. Because, as we said previously, FH is equal to FA, and then in this triangle HFA there is two equal sides, and that means the triangle is isosceles at the vertex F. B. What does FO represent to the angle HFA? Since HF and AF are tangents to the circle, so FO is the bisector of the angle HFA. Show that SO is parallel to AE. Knowing that the perpendicular bisector of FO cuts FH at S. So this is the point S. The perpendicular bisector of FO that goes through the midpoint of FO and perpendicular to FO, if we elongate FH, the perpendicular bisector of FO cuts FH at the point S. So this is the point S. So now we have to show that SO, the side from S to O, is parallel to AE. Since S belongs to the perpendicular bisector of FO, so SO is equal to SF. So the triangle SOF is isosceles at S. So the angle SFO is equal to SOF as angles. And we have that SFO is equal to OFA because FO is the bisector of the angle HFA. That means SOF is equal to OFA as angles. And we have that SOAF and OFA form alternate interior angles. Because of the alternate interior angles, we have the parallel now. So SO is parallel to AE. Here the figure again. Deduce that the triangle ASB is isosceles with vertex S. So we have to prove that SA is equal to SB, or the angle at A is equal to the angle at B in this triangle. SO parallel to AE proved previously. We have EA perpendicular to AB, proved before because of the tangent. So SO is perpendicular to AB. And also O is the midpoint of AB. So SO is the perpendicular bisector of AB because it passes through the midpoint of AB and perpendicular to AB at the same time. And because S belongs to this perpendicular bisector of AB, that gives us that SA is equal to SB because any point on the perpendicular bisector is equidistant to both extremities. So the triangle ASB is isosceles with vertex B. Show that the 4 points A, F, H, and O belong to a same circle and determine one of its diameter. We have to prove that A, F, H, and O belong to a same circle, and we have to determine its diameter. The triangles OFH and AFO are two right angle triangles having a common hypotenuse OF. So the 4 points A, F, H, and O belong to a same circle of diameter OF. This is the circle in green.